X-rays, basically. All right, but it is still an effect of photoelectric absorption because they both start off with an incident X-ray photon coming in to the atom, but it doesn't. The Auger doesn't result in the creation of the characteristic photon. Okay. All right. So the probability of photoelectric absorption, it increases as your atomic number increases. So if a tissue has a high atomic number, there's more chance of photoelectric absorption happening. All right. For example, if you take a look here at these different atomic numbers, compact bone has an effective atomic number. It says effective because bone is not just made of calcium. It has different materials that's in the bone. That's why it's effective. So it's sort of like an average of everything that's in the bone. So bone has the highest, which is 13.8. Soft tissue has 7.4, and air has 7.6. So out of these three, which one do you think experiences photoelectric absorption the most?
13.8.
Bone, because it has the highest atomic number. And because air and soft tissue are sort of similar, they have the same amount of probability when dealing with photoelectric absorption. So if I asked you a question, which interaction is affected by atomic number, what would be your answer? Photoelectric. Because it's dealing with the inner shell of the electron. So the higher the atomic number, we're dealing with higher inner shell energies in the atom. So that is dealing with photoelectric, because we know that it deals with the inner shell. Okay? So higher the atomic number, higher binding energies in the inner shell, therefore it affects photoelectric, because in photoelectric we know that we deal with the inner shell electron. All right. Your body part thickness and density also affect the photoelectric absorption. For example, if you have two structures that have the same density and same atomic number, but different thickness, we know that the thicker part is going to absorb more photons. Why do you think that is?
More
dense.
No, so it's same density, same atomic number,
Mhm.
but let's say one is thicker, a lot thicker than the other. The thicker part is going to absorb twice as many photons. Why?
Because there's more.
That's right, because there's more tissue that's going to stop it from transmitting, correct?
Mhm.
So a lot more will be absorbed. And that's the simplest way to answer that question. Attenuation, we know that attenuation is a loss of intensity or reduction in the intensity of something. So it can either be absorbed or it can slow down and change direction. So air has 1,000 times less density than soft tissue. So that's why air allows for more transmission to happen. What do I mean by density? What does it mean if I say something is less or more dense? What exactly are we talking about?
Less
stuff. It's less stuff. So less atoms per volume of tissue. So air, atoms are probably just floating around. It's not tightly packed like bone. So that would allow for more transmission to happen and less absorption. Bone is very tightly packed, more dense, so there's a lot more things that can block the beam, right? Which is why it leads to more absorption. As simple as that. And if we have higher attenuation, we get a lighter image, right? How?
More penetration went through.
Higher attenuation, we get a lighter image. Lower attenuation, we get a darker image. So take a look at these two images. Which one's higher attenuation?
The left.
The left one, because attenuation means that it's absorbed.
Oh, yeah.
Lower attenuation, meaning more went through, which is why it's dark. And that is how we select our techniques based on what kind of contrast we want to achieve with our x-rays, right? So if we use higher KDP, it decreases photoelectric absorption. So our image will look what? Light or dark? Dark, because it's decreasing absorption. Y'all look confused.
Yes.
Oh, I'll send it to you, don't worry. So if we use higher KDP, that means we just increase the penetrating ability of the beam, correct?
Yes.
Mhm.
So we have less absorption, but more penetration or transmission. So our image will look
Darker.
dark. So it decreases the image contrast. So it's gonna look like the image on the right. See the KV meter right there? KV is high. But if you have lower KVP, meaning our beam is not gonna be as penetrating, it's going to get stuck in the tissue, it's gonna look light. So in order for us to have different shades of gray, meaning really good contrast, we want more absorption to happen. Okay? Any confusion? Okay. So, if we had to image the intestines, which naturally don't have that good of a contrast, we have to have the help of something that will increase our photoelectric absorption, such as barium. Barium has a high atomic number, we know that, right? Which is what?
56.
Correct. So it increases the attenuation, meaning more will be absorbed, it's going to look bright. And then we also want help from negative contrast, such as air, which decreases attenuation and gives us that dark contrast. Okay? So barium increases attenuation, air decreases attenuation. So which one of the two contrasts enhances photoelectric absorption? Barium.
But if it one makes it dark and one makes it light,
So air is going to have more transmission, less attenuation. Barium's gonna have more attenuation, less absorption. So barium is the one that deals with photoelectric absorption. Alrighty. Moving on to Compton. Compton, we are dealing with which shell? Outer shell. Compton has an O, outer shell. Do I need to get into the detail of what happens?
yeah, ma'am, please.
No?
No, ma'am, please do, please.
Muncie, why don't you tell us?
Vote on it.
Oh, man.
What happens in Compton scatter?
So this is, after the tube, so that means it's an incident, photon
Mm-hmm.
that's going to come into the patient's body and interact with the outer shell electron, outer shell electron. And, it has enough energy to kick out the electron, so it's gonna use 1/3 of its energy to kick out the electron, and the remaining is gonna leave as a scattered photon.
Okay,
And it's gonna create ionization.
correct, because it's removing an electron from the atom. Other names for Compton scatter is incoherent, inelastic, or modified. And Compton is responsible for most of the scatter radiation that we deal with in X-ray, small angle, backscatter, and side scatter. So this is basically just what Muncie said, is interaction between the X-ray photon and the outer shell electron. Some energy from that photon is absorbed by the electron, and it kicks the electron out, and then the rest of the energy is converted as a scatter.
Same thing that we just
Mhm.
in this one class.
Yep.
about 10 minutes ago.
So the ejected electron that we deal with in Compton scatter is known as a Compton electron, also secondary or recoil electron. So those are all the same name for the electron that's been ejected. This electron can interact with other atoms and increase patient dose also. Okay? It does not contribute to the radiographic image. Why?
I thought it did.
It decreases that contrast.
Oh, yeah, because it decreases.
Has a negative effect, causes fog.
I feel like I probably shouldn't have put that on there. Ignore this. I'll take that off.
No, that's a fact, an actual one that we just learned.
Does not contribute to the radiographic image.
It does not, it decreases the contrast, the scatter does.
So
It
I
doesn't-
guess it means it doesn't
Positively.
positively contribute to the image?
Yeah,
Okay.
negative.
That's what I mean.
But it doesn't matter, cause it does not contribute to
Yeah.
the
It decreases
radiographic image,
contrast,
cause we
right?
wanna see a good image.
It,
That was a test question.
Mhm.
yes.
contribute to the image. It negatively affects.
Yeah.
That's negative,
In this
that's
case,
not
contribute
contributing to the
meaning
image,
like
Nancy. You
the
wanna
the
bring
wording
it
that
in.
I chose was not
Yeah,
that
the
great.
wording.
So it doesn't
Okay.
positively influence in creating the image.
I thought we
Let's
always
not,
want a
let's
positive
not
image.
start fighting now.
But I thought we always want a good image, like, it doesn't make sense to say something negative. You don't want a negative image, that's the whole purpose of this class, you want a good image, like, come on.
Yes, but
Goodness.
there will be interactions that
That
are negative.
have negative effects, but
On the
that,
image.
if you say it does not contribute to the image, I'm gonna assume to a good image. It's just,
I guess I will reword this as does not
Positive.
positively contribute to the radiographic image. It just creates fog. So the electron that was ejected, it can continue in a different, the incident X-ray photon can continue in a different direction with the remaining energy that it has and still keep on going through other interactions, either photoelectric or Compton. It can also exit the patient. It can hit the IR to cause fog, and then it can also hit nearby personnel to cause increased dose. So the X-ray photon that came in does not stop, it keeps going in a different direction.
But it has less and less energy.
Yes. So Compton, once again, is not dependent on your atomic number. It does not differentiate between soft tissue and bone. And it doesn't really help in creating good contrast, but it does create fog. It does depend on the energy of the photon and the density of the part. So if the photon has a higher energy, it increases the ratio of Compton to photoelectric interactions. And then if a part has higher density, that also increases the probability of Compton interactions. But if this is the KEV, the probability of Compton and photoelectric is about equal chance of happening. Okay? Alright, pair production. Who remembers this? Charo?
everybody. We just don't talk about it that much, cause, you know, it's not, very constituent.
Yes, so for pair production to happen, the X-ray photon needs a minimum of 1.02 mega electron volts. So that's higher than normal energy that we would use in X-ray. So this is when the X-ray photon interacts with the electric field of the nucleus, and the photon is absorbed and converted to two particles. One is a negatron, which is electron, and then one is a positron, which is a positive electron. Okay? So the incident photon needs to have at least this much energy, and then it interacts with the electric field of the nucleus, resulting in a positron and an electron. So the energy of these two will be half of what it initially started off with. So the electron that was produced ends up being captured by neighboring atoms that may need an extra electron in their outer shell. And the positron, which is antimatter because it has opposite charge of the electron, when it interacts with another electron, it undergoes what's known as an annihilation reaction. What does that mean? Basically just they kill each other or annihilate each other. And the result of that annihilation reaction is the creation of two photons that have the same energy. And they travel in exactly opposite directions. Okay?
But
Yes.
this is not opposite though, what you've shown. In two directions you mean.
This is
Two
not my
directions.
picture.
Probably
But yes,
two
it says in
directions.
exactly opposite directions.
Yes.
Mhm.
The positron creates photons. Two photons.
Yes. Mhm.
Well, that picture's not showing an annihilation event. That picture's showing pair production. The
Yeah,
annihilation
this,
event is
this
something
picture
else.
is
Showing
pair
that it's
production.
Yeah.
Oh, yeah.
It's not showing annihilation, yes. Thank you, Cody. So this is showing the initial interaction between the photon and the what? Not the electron.
The positron and
So let's start over. We have an X-ray photon with an energy of 1.022 MeV. It comes in and interacts with the what?
Photon nuclear electric field.
Electric field of the
Nucleus.
nucleus. Okay? And then what happens?
It annihilates.
That was horrible.
Not yet.
Then a positron and an electron.
Photon is absorbed.
The photon is absorbed by the electric field of the nucleus, creating two particles. We get an electron and a positron. Okay? Now, the electron from our previous incident ends up being captured by atoms that may need an extra electron in their outer shell. But what happens to our positron?
It could hit another electron
it's
and
another-
cause an annihilation event.
It can interact with another electron and cause an annihilation reaction, which creates two photons that travel in different directions or opposite directions.
So positron is the one that does the annihilation reaction.
Yes, the positron is the one that's involved in the annihilation reaction with another electron. What happens to the first electron?
it's
Good.
captured.
Captured by another atom that needs an electron in the outer shell. Alright, so where would we see this? In PET, or positron emission tomography. So we know that radionuclides, they undergo decay, and what happens during decay?
They-
Particles are emitted, correct? And one of the particles is a positron. So what happens is the positron reacts with a nearby electron to form an annihilation reaction, and then the photons that are produced through that is what is imaged in PET. So the detector that's around the patient, it picks up the photons and creates the image that they look at. Yes. And I believe this is the last interaction that we'll talk about. Photo disintegration. This one requires a minimum of 10 mega electron volts.
Bless you.
Bless you.
This is an interaction between a photon and the nucleus. And the nucleus can eject any one of these particles. Not all four, just one of those. And that's all you need to know about photodisintegration. requires a minimum energy of what?
10.
10. And interaction between photon and nucleus. And then any one of these can be the result of this phenomenon. Deuteron is a proton and a neutron together. Yes.
So this one would be specifically the nucleus, but pair production would be the
Electric field of the nucleus.
Okay.
I don't even know the difference. I'm not
It's
not a physicist. And that's the end of chapter 3, guys. We made it. So let's see if we learn anything. Read this question to yourself and think about the answer. Ellen, read this question and think about the answer. Think about the answer, don't say it out loud. Y'all ready?
Yes.
And the answer is
X-ray
D.
photons.
D, X-ray photons. The key word was traveling at the speed of light. And we know that X-ray travel at the speed of light. Alright, next one. Don't say it out loud, please. Ready? Okay, what's the answer?
A.
That's correct. And the answer is
B.
Rams.
Ramshaw. By the way, all of these questions will be on the final. I mean, on the exam. And the answer is what? That is correct. This one's easy. It's 13.8. See? Yay!
I have a question on the
Oh,
one
yes.
with the outer shell.
Did she get an answer?
The,
Yeah.
Was it the cascade effect? Is that what I was characteristic on that one?